project is enhance the performance of PV-based SEPIC DCC conversion automation algorithm. Myself, Nitin, I'm currently pursuing BEE in Mepcoastal Engineering College. Our colleague mates are Prasant and Rohit Permal. Project is guided by Dr. Invadaja, Assistant Professor Senior Credit, Triple Department, Mepcoastal Engineering College. These are our contents. Objective to propose the control structure of MPPT system which is able to track very fast nature changes and to maintain stability of overall closed loop system is guaranteed for a different load scenario to design a robust optimization control that maintains and prevent voltage oscillations to the environmental variations. This increasingly affordable due to the cost progress supporting technology that directly converts solar radiances into electrical without any intermediate power conversion. The controller is required to track the maximum power point due to changes of sudden irradiance. Existing system, a novel coupled of single-ended primary conductor is presented. Some auxiliary components are added like topology to give higher gain components, and these are our equations. The gating pulses for both switches are same and wide output resistance can be achieved only by changing duty cycle ratio. Block diagram, the solar PV SEPI converter load MPPT algorithm. The solar is controlled by MPPT of perturb observe algorithm, the giving gating pulses to the SEPIC DCC converter, and the supply is given to the load. Thank you.
Greetings to all, myself Jeroid Thermal. You can see the modes of operation of SEPIC converter. Mode 1 operation. The input voltage of Vin drops across L1. Once S1 operates, so the current IL1 rises. DA enables capacitor CS to charge as the output capacitor C0. The L1 energy transfers together with the L2 when S1 goes off the load RL until it reaches both C0 and L2. Next, mode 2 operation. The input inductor L1 establishes control over the input current through its energy store. The release activity is controlled by the switching devices S1 and S2. S1 enables the input voltage Vin to act across L1 during while IL1 start to rise. Both the capacitors CS charging power from the diode DA. Yet the output capacitor C0 provide electrically to sustain the load. Stored energy from L1 distributes to CS and L2 simultaneously. So mode 3 operation. The input inductor L1 controls the input current flow through its storage and release functions during on-off duty cycle for switching device S1 and S2. L2 and C0 works to smooth the output voltage while decreasing ripple. The output capacitor C0 together with the output inductor L2 in the output voltage level to stabilize. A symbolic diagram of SEPIC converter without MPPT. Here the input source is given as solar PV. The irradiance value is given to the solar PV to increase or decrease the value of irradiance value. This circuit to step up the input voltage comes from the solar. Getting pulse is given to the switch S1 and S2, and the waveforms have been taken from the paper. Here the input voltage is nearly 30 volt is given as input, and the output voltage step up is 200 volt nearly.
Rohit Permal has explained well. I am Prasant from Mepcoastal Engineering College. MPPT P&O method. The P&O method observes periodically changes of the voltage and it also measures power and it introduces preterption slightly increase or decrease and it observes power changes so that increase continues to beat up in the same direction and decrease and the reverses in the beat up direction. Here the so that the input and output voltage fluctuation can be reduced. Here the hardware setup consists of solar panel and the 12 volt battery setup and it connected to the hardware. Here are the outcomes. It consists of no voltage oscillation, reduced calculation complexity in MPPT, simplifies the transfer path faster and more efficient, and internal and external route strategies. Here the outcomes: the integration with output and linear integration, and these outcomes collectively contribute. Social impact: it consists of DC microgrid, solar vehicles, and standalone systems easily emergency due to grid connected inverters and it solar connection stations and renewable power sources. Thank you.